Good day, good day, good day. How are you doing? How are you doing? How are you all doing? It's a good code, code Wednesday. Thank you so much for those who are able to tune in with us. Thank you so much. Please share the link with friends and family so that we can prepare for our June exams. So that we prepare together our June exams. Share the link. Then we get down to the business of the day. If it's your first time, don't forget to subscribe, to like, comment, to share with friends, to share with family. And also we have our WhatsApp group. The description of the video is just here. You click on the description of the video, then you receive the video, the WhatsApp group which we have. Also, you can tune in for our Facebook page, which is written Yebo Tutor NMU, so that we can assist each other. I'm so happy to be with you guys today, and I hope we will enjoy it together. Right, so just share. Then we can start today with the business of the day. Okay, we can start with the business of the day. All right. Okay. Okay, great. Let's start with whatever we have to do today. Today we'll be doing analytical geometry and Euclidean geometry. So we'll be a bit fast so that we can be able to cover a lot of things which we have already done. So bear in mind that if you want the basics or the concept behind Euclidean geometry, I would definitely urge you to look at our videos which we have already done on analytical geometry when I gave an overview of the whole video as a whole. So please do check the video out, and please do check the video out and have the basics before you try to apply it. So here we go. So today we'll be doing analytical geometry as well as Euclidean geometry, the basic, the boss of paper 2. Now let's go to question number 3. If you have any question, write your question in the WhatsApp group. We'll attend to it, or you can just type on the comment sections and say, please can you repeat this? Please can you assist me in this? So now let's go down and let's go down and let's go down. Okay, question 3. So we are given that in the diagram A, which is coordinate -7 is to 2, B and C, which is 6 is to 3, and D are the vertices of a triangle ABCD. The equation of line AD, where is AD? Oh, we can see that AD is equal to 2x plus 16. Then line AB, where is AB? Okay, that's line AB. It cuts on the y-axis at G. So we already know that G is a y-axis. So if G is a y-axis, which means the coordinates is 0 is to y, which means the x-intercept is equal to 0. Because when we were calculating, when we were doing our function, we said that when we are plotting, when we want to know the y-intercept, we let x to be 0. So for the fact that they already tell that AB cuts y-axis at G, which automatically tells us, or which automatically give us the idea that G already has a coordinate which is 0 is to y. Then the x-intercept of the line BC is F. We already know that if it's an x-intercept, the y value is equal to 0. Then now, the angle of inclination of BC with positive x-axis is alpha. So what do we know about the angle of inclination? We know that the angle of inclination means that tan of that specific angle is equal to the gradient, which means the gradient and the angle alpha, they co-hint or they align together. So you must be able to calculate the gradient so that you can get the angle of inclination. Then the diagonals of a rectangle intersect at M. The diagonals of a rectangle intersect at M. So we can actually see that M is the midpoint of both line AC and both line BD. So what do we know about the midpoint? We know that we are using the midpoint to calculate the coordinates of that specific point, and we can actually use it using a specific formula, which is amazing. Now let's go. Question 3.1, calculate the coordinates of M. So we analyzed and we were able to see that M is the midpoint of line AB, AC, and also line DB. So now we know the coordinates, or we know how to calculate the midpoint. How do we calculate the midpoint? Let me do this. How do we calculate the midpoint? So the midpoint, we calculate the midpoint by using this formula. Calculate the midpoint by using this formula. Let me see. Calculate the midpoint using this formula. Calculate the midpoint using this formula. 3.1. So the midpoint of a line AB is x2 plus x1 divided by 2, then y2 plus y1 divided by 2. So that's the midpoint. Then now, going up, we already know that that's our formula. So since that is our formula, what do we do from that? Now we substitute. We are given the coordinates of line A. We said M is the midpoint of line AC. Let me just do this so that we can see that M is a midpoint. M is a midpoint of line AC. So here we are calculating the midpoint of line AC. So we know the coordinates of A and we also know the coordinates of C. So now the next point is going to be M. Then we have -7 plus 6 divided by 2. And what is our y coordinate? We know that it's going to be 2 plus 3 divided by 2. Then we use our calculator. Then M now will be equal to -7 plus 6 is -1. So it's going to be -1 over 2 on this side. And also 2 plus 3 is 5. Then 5 over 2. So that will be our coordinates. So that's, we're able to realize that it's a midpoint of line AC. Cool. Now let's move forward. What is the next question saying? The next question is saying that write down the gradient of line BC in terms of P. Write down the gradient of line BC in terms of P. So how do we do that? How can we write the coordinates of the gradient of BC in terms of P? So we know for sure that the gradient of line BC, or 3.2, the gradient of line BC is equal to, we know that is y2 minus y1 over x2 minus x1. What is the coordinates of oh, okay, they said write down the gradient in terms of P, so we can actually say BC, but now let's go and write it. Okay, sorry for that. Yes, the gradient of the line BC is the same as the gradient of line CF. Do you see that they are collinear? They are collinear points. So it's actually the same thing. So in actual words, so now we can definitely calculate the gradient of CF. Okay, so we can definitely calculate the gradient of CF here. So how do we calculate the gradient of CF? We know that the gradient of CF will be equal to y2 minus y1 over x2 minus x1. So now equal to again, then now we can actually move forward. Then we move forward. Let's move forward together. So it's gonna be 3 minus 0 over, what do we have? We know that it's going to be 6 minus p. So we can see that the gradient of CF will be equal to 3 over 6 minus p. 3 over 6 minus p. But we know that, you can actually say that, but we know that the gradient of CF is the same as the gradient of BC. So therefore, the gradient of BC is equal to 3 over 6 minus p. They are collinear points. Why? They are collinear points. All points are located in a straight line. So that's now, and that's what we have now. Okay, that's now what we have. Is there anyone with any question? Is there anyone with any question? Please do ask if you have any question. If you have any question, ask us so that we can assist you. All right. Now, let's move forward. Let's move forward. Now, let's move forward. 3.3. Now, let's move forward. 3.3. Let's move forward on 3.3. Right. Now, on 3.3, they say that calculate, hence calculate the value of P. How are we going to be able to calculate the value of P? How can we calculate the value of P? They are saying that calculate the value of P. How are we going to be able to calculate the value of P? The value of P. Now we know the gradient. We know the gradient. So how can we calculate the value of P? Can someone just type something there? How can we calculate the value of P? How can we calculate the value of P? Okay, great. So how can we calculate the value of P? We know that the gradient of AD is the same as the gradient of BC. Is the same as the gradient of a DC. Okay, we know that the gradient of BC. Let me just do this. Fix something. So we know that the gradient of, wrap this. We know that initially the gradient of AD is equal to the gradient of BC. Why? They are parallel lines. We know that the characteristics of a rectangle is that the opposite sides, they are parallel and equivalent to each other. So since they are parallel lines, which means now we know that the gradient is the same. And what do we know about the other point, or what do we know about the point, the gradient of AD? We know that on AD, we know that we were given an equation which is y is equal to 2x plus 6. So we know that this 2 is representing the gradient, because the equation of line, it's y is equal to mx plus c. So what is m? M is our gradient. So the gradient in this case is going to be equal to 2. So therefore, we now know that the gradient of AD is equal to the gradient of BC is equal to 2. So now we now substitute. What is the gradient of BC? We calculated initially, and it was 3 over 6 minus p. So it's going to be equal to 3 over 6 minus p is equal to 2. Then after that, we cross multiply. Then we have 12 minus 2p. Then we solve for p. Then it will be 2p is equal to 12 minus 3. Then 2p will be equal to 9. Then divide both sides by 2. Divide both sides by 2. Then our value of p will be equal to 9 over 2. Our value of p will be equal to 9 over 2. So what did we do? We used our our gradient which we calculated initially. So what do this thing tell you? It tells you that in all the questions which we have, in all the questions which we tackle, we have to understand that the previous question, we use the previous question to get the next question, we use the next question to get the other question. So that's how it always works. So now we know the value of P. So therefore, we can actually say that, or we can actually label on our diagram that the coordinate of F is now 9 over 2 is to 0. Okay, you can actually do that so that you can do your calculations well. Okay, now let's go to the next question. Let's go to the next question. On question 3.4, this is interesting. Calculate the length of dB. Calculate the length of dB. How are we going to calculate the length of dB for 3 marks? How are we going to calculate the length of dB? How are we going to calculate the length of dB? We know that the length of dB is the same as the length of AC. Why? The diagonals of a triangle are always equal. So the first thing which you must be able to see is that dB is equal to AC. Then what's your reason? Why are you saying that they are equivalent to each other? It is because the diagonals of a rectangle are equal. Okay, let us know that. Write your reason so that we understand what are you doing. So what is important in analytical geometry and Euclidean geometry is to be able to have a clear understanding of your all shapes, your all quadrilaterals, know its characteristic, that this is a rhombus. The two opposite sides of a rhombus, they are equal. These two also, they are equal to each other. Know the characteristics of a square. All sides of a square are equal. Know the characteristic that if it's a square, all the interior angles, they are 90 degrees, 90 degrees, 90 degrees, so that you can be able to apply and use the same knowledge which you know about the specific shape which you are given. So in this instance, we are given a rectangle. So one of the attributes or one of the things which we know about a rectangle is that all the diagonal lines, they are equal, and also the opposite side of a rectangle, they are parallel to each other and are also equal in sizes. So what do we know now? Since now we know that dB and AC, they are the same, and we also know that AC has both coordinates. We are already given the coordinates of A and coordinates of C, so we can actually calculate the distance of A, C, and we know that the distance formula says that x2 minus x1 all squared plus y2 minus y1 all squared. Okay, then after that, let's substitute, and now let's have our values. So it's gonna be 6 plus 7 squared, just 6 minus 7. Okay, so that you don't say I'm confused. Plus, what do we have? We have 3 minus 2. Then after that, don't worry yourself. This is only 3 marks. Don't worry yourself trying to solve things. Don't do that. The moment you are at this step, use your calculator. From the get-go, then you're going to get your square root 170. Then therefore, the length of AC is equal to square root of 170 units. Then we can also conclude that the distance of dB is equal to square root of 170 units. All right. Then if you want to write it in decimal, it will be 13,04 units. Okay. Now let's move forward to our next question. If there is no one with any question, now let's move forward to our next question. The next question is 3.5. We are trying to move fast as we can. 3.5. Okay. So now they're saying calculate the size of A. A is in alpha. So what do we know? On the statement, we were told that the angle of inclination of BC. So we were told that in the statement that the angle of inclination of BC is equal to alpha. So what does that tell us? Now we know that in order for us to calculate or determine the angle of inclination, we always use the same theory that tan of alpha in this case will be equal to the gradient of line BC. And now we know the gradient of line BC because we say that line AD and BC, they are parallel to each other. So in other words, they have equal gradient. So what do we have here? We have the gradient of BC to be equal to 2. Then alpha will be equal to arctan of 2. Then we use our calculator. What's the answer? Then we use our calculator. What is our answer? If we use our calculator, so we got 63,43 degrees. I also used my calculator here. Then we were able to get our answer, which is 63,43 degrees. 63,43 degrees. Can someone confirm my answer as well? Okay. Okay, thank you. Now, let's now look at our question 3.6. Now, they say that calculate the size of OGB. Where is angle GB? OGB. So we need that size of OGB. So how are we going to calculate the size of OGB? How are we going to calculate the size of angle OGB? So what do we know? We know that we can solve this in different ways. We can use the fact that OFB, let's just use that one. Let's use the fact that OFB is equal to alpha. I don't know if you can see that. Let me try to just draw this thing so that you can see, so that you can actually see what I'm talking about. I always love saying drawing. Drawing is powerful, even if I'm not good in drawing nice plots. I trust that something which can actually change your life. See my drawing, my ugly drawing. So now we have the diagonals here, which is A, C, D, B, and F. Then we're given alpha. Then we have G here. Then this is O. Okay, cool. Let me use a different pen. Great. Now, they want us to calculate the size of OGB. This is the size which we are supposed to calculate. So, we now know the angle alpha here, that alpha is equal to 63,43 degrees. Okay. Then we know that this and this, they are opposite, they are vertical opposite angle. So, this angle and this angle, they are the same. So, in other words, we are saying that FB is equal to 63,43 degrees. Why are you saying that they are vertically opposite angles? Vertical opposite angles, they are always equal to each other. Then now, we are looking for this angle. We are looking for that angle. Don't forget that we are looking for that angle. Okay. We are still looking for that angle. We are looking for that angle. So what are we going to do about the fact that we know that OFB is equivalent to that? So now we can see also that angle FOG is equal to angle GBF, is equal to 90 degrees. We know that it's 90 degrees. Angle angle FOG is equal to angle GO is equal to GBF, because we know that at the corners of a rectangle it's 90 degrees. So we already know that, and you can see that on the 90 degrees, when we're doing our trigonometry, we know that on the reduction formula that when we cross here like this, now we already know that it's going to form a 90 degrees. So now we have our 90 degrees of that angle and that platform. So what does that tell us now? Then now we can actually calculate angle OGB. So we can calculate that. Therefore, angle OGB is equal to 360 degrees, because the total of all angles in a rectangle, they add up to 360 degrees, minus, then we add the angles 90 plus 90 degrees plus 63,43, so that we can actually have that specific angle. Then we can actually say that it's sum of, just for reason, write a reason that it's sum of angles in a quad. All quadrilaterals, they add up to 360 degrees. Then let's use our calculator. 90 plus 90, it's 180. 180 plus 63,43. We are using our calculators, all of us. Let's use our calculators. Then 360 from the total. Then I'm finding 116 57 degrees. So this is the angle which we need. Angle OGB is equivalent to 116.57 degrees. Okay. All right. Let's move forward and do 3.7. It's a bit tricky. So 3.7 says that determine the equation of circle passing through points D, B, C, passing through point D, B, C. Okay, this is the circle passing through D, B, C. So it's the circle passing through point D, B, C. Calculate that coordinates. Sorry for that. Let me just double check this. Okay. Now we're on 3.7. We're now on 3.7. Okay. Now let's calculate on 3.7. Okay. How are we going to write that in the form of x minus a squared plus y minus b squared is equal to r squared? So now let's write it down. Let's write it down. We know the coordinates of M as the midpoint, that M is -1/2 and 5/2. Right. So we know that. And this is now the center. It is the center. So now we just have to calculate the radius. The radius is equal to half the length of DB. Just gonna be square root of 170 divided by 2. Then that's our radius. Then now let's write the equation. Therefore, the equation will be x minus 1/2 all squared plus y minus 5/2 all squared is equal to the radius, square root of 170/2 all squared. Then that will be x plus 1/2 squared plus y minus 5/2 squared is equal to 170/4. Is equal to 170/4. 170/4. This, when you reduce this is going to give you 2 into this, then you have 85. Let's use it in the reduction way. 85/2. You have 85/2. Let's use it in the reduction way. Okay, then that will be our answer. Then the next question says, if AD is shifted so that ABCD becomes a square, will BC be a tangent to the circle passing through points A, M, B, AM and D and B, where M is now the intersection of diagonals of the square ABCD? Motivate your answer. Will BC be the tangent? Okay, how can we motivate our answer? So we have studied together that 3.8 we know, and we have studied that CBM, as we can see, where is our show so that you don't say I'm saying something. CB, this is the diagonal, this is M, the center. So we are saying that CBM is equal to BAM. They are both equal to 90 degrees. Oh, sorry, 45 degrees. The equivalent to 45 degrees. Why? According to the principles, or according to the characteristics of a square, we know that the diagonals of a square, bisect the angle. Diagonals of a square bisect the angle. The diagonals of a square bisect the angle. So we can actually therefore convert that BC is equal to 90 is a tangent. Y converse tan chord. Converse tan chord theorem. That will be our reason, converse tan chord theorem. Oh, someone will say that, no, check it out in this angle, Vuyani, 3.8. Let me just say option 2. Someone will say, no, check it in this angle. If we draw our triangle in our square in such a way, it's A. Okay. So it's A, B, C, and D. Okay. This is our square. Then we know that the diagonals of a square, when they cut each other, they bisect each other. Okay. Then we know that this is our M. And we know that this alone is 90 degrees. And also this is 90 degrees. So if we hold this length BC, we can actually see that this angle will be equal to this angle. We can actually see that this angle will be equal to that angle. So we can actually write in this way that angle AMB is equal to 90 degrees. Y, diagonal of a square, the diagonal of a square, bisect perpendicular. It's 90 degrees, and the diagonals of a square bisect perpendicular. Okay, if it bisect perpendicular, so what does this all have to do? So therefore now we can actually see that AB is a diameter. We know about semicircles as well. So now we can actually see that it's a diameter. So therefore we can actually see that BC is perpendicular to line AB. Then now we can conclude that BC is a tangent. Why is BC a tangent? Because line perpendicular to the radius. Or you can say that converse tan chord. When you are proving something that this is tan chord theorem, you don't say tan chord theorem as a reason, you say converse. If you are proving that the line from the center to the circumference bisect or is perpendicular, you cannot use that. You must say converse of that specific length. So now, here we are. Now I want us to move forward. This was my analytical geometry. Now I want us to also touch on trigonometry. I want us also to touch Euclidean geometry. So we're going to do Euclidean geometry right now. We have already done the analytical geometry part. Now we must do the Euclidean geometry part. Euclidean geometry. Let's do the Euclidean geometry part. Guys, if you have any question, please do ask. I'm here for you. Please communicate with me. I'm here for you. I'm here to assist you. We'll do question 8. Yeah, let's do question 8. Let's do question 8. I'm here for you. Let's do question 8. Okay. Question 8, question 8, question. Are we ready for Euclidean geometry? Right. So on question 8, in the diagram below, PQRT, let me maximize the screen. Okay. In the diagram below, PQRT is a cyclic quadrilateral. What do we know about a cyclic quadrilateral? We know that a cyclic quad, all the opposite angles or the angles of a cyclic quad, they are supplementary. Okay, the opposite angles in a cyclic quad, they are supplementary. So when we're saying they are supplementary, which means they add up to 180 degrees. So they are supplementary and they add up to 180 degrees. The beauty of that. Okay, so now we're already analyzing that. Okay, we have PQ RT. So now we already see that P2 is equal to angle R. They are both equal. P2 plus P plus angle R is equal to 180 degrees. Supplementary angles. We also see that T2 plus T3 is plus Q2 Q1. They will give us 180 degrees. Supplementary opposite angles of a cyclic quad, they are supplementary, and we can actually see that angle Q as a whole is equal to angle T1. You see, so because when we touch that chord PT, then it will subtend on angle Q1. Yes, is it? Yes, because we can see that, yeah, can subtend there. And now we are also given that TR and PQ are perpendicular to each other. What does that make you feel, or what does that make you see? It makes you see that Q1 is equal to T3. Do you see that Z which is being formed? T3 is equal to Q1, Z alternating angles. Then when we look at this perspective from PQ, we can actually still see that Q1 is equal to T3. Now, we can also see that also angle R plus angle Q will give us 180 degrees. They are co-interior angles of they are co-interior angles. Then you write the parallel line. So now we've already explained the whole question. We don't know what we are asked, but we already analyzed the question in all the aspects which you have but assist us. So now let's hit the road. Let's answer the question now. Let us now answer the question. Let's remove this one. Let's do this. Okay, let's do this. Let's answer the question now. Question 8. So on question 8 now, we are answering our question on question 8. Question 8. Now, first question, give a reason why P2 is equal to 70 degrees. Where is P2? Okay, we have P2 there. Why is P2 70 degrees? Why is P2 70 degrees? As you can see, why is P2 70 degrees? So P2 is equal to 70 degrees because P2 is equal to 70 degrees because why, guys? Why? We see that they are parallel lines, but why is PT equal to 70 degrees? Why? Why is PT equal to 70 degrees? Let me see something. Okay. Okay, that's better. So let's answer our question. So 8.1, P2 is equal to 70 degrees. Why? They are alternate angles. Then you state the parallel sides. What are the parallel sides? PQ is parallel to SR. Okay, then that's great. It's parallel to SR. Now let's look at the next question. 3 marks. 8.1.2. What is the A? What is Q1? What is Q1? How are we going to see the angle Q1? What do we know? We know that now since P1, or since P2, sorry, is equal to 70 degrees. What is T2? T2 is equal to 70 degrees. Why? Angle opposite equal sides. Angle opposite equal sides. Did you see that TQ is equal to PQ? They are equal sides. So for that fact, now let's start by saying, since we say that P2 is equal to 70 degrees, okay, so now we are saying that angle T2 is equal to 70 degrees. Why? Angles opposite equal sides. Angles opposite equal sides. Angles opposite equal sides. Then now we now know the angle T2, so now we can actually calculate, sorry, excuse me, we can actually calculate Q1. Now we can actually calculate Q1 after we know that. Okay, So we can conclude that therefore angle Q1 is equal to, we know that P2, okay, let me just do this. So therefore P2 plus T2 plus Q1 is equal to 180 degrees. Why? Sum angles of triangle. P2 is 70, T2 is 70. We must calculate angle Q1 equal to 180 degrees. So making Q1 the subject of the formula, it will be 180 degrees minus the summation. 70 plus 70 is 140. So angle Q1 will be equal to 40 degrees. Angle Q1 will be equal to 40 degrees. Great. Now the next question, which is 8.1.2b, they said calculate or determine the angle P1. Where is P1? Now we can actually say that P1 will be equal to Q1, because when we hold that tangent SP, and now the chord which that tangent SP is that side. So now let's look at the chord. We can now see that P1 has a chord PT. So when we hold that PT, it will go and subtend on the circumference on angle Q1. So therefore P1 is equal to angle Q1 is equal to 40 degrees. Why? Tan chord theorem. Tan chord theorem. It's tan chord theorem. That's why. It's tan chord theorem. Tan chord theorem. Tan chord theorem. Now we have 8.2. Okay, let's analyze 8.2 together. So what I've taught you is that the first thing we should do is you look at the question and what you are given. Then you analyze from that. Okay, now the first question says that A, B, and C are points of the circle centered at O. Okay. S and T are points on AC. S and T are points on AC and AB respectively, such that OS is perpendicular to AC, Okay, so in other words, if they are perpendicular according to theorem 1 of Euclidean geometry, which means that AC is equal to CS. Then now the length AB is 40. Okay. Also, we know that from that perspective of AB, we know that AT is equal to TB. Then we're given AC to be 48. So AS will be half. So those things, they are just bisecting each other. So, right. Calculate AT. Where is AT? That's easy, guys. AT will be equal to half of AB. Let's write it down. AT. We do this. Okay. So AT. 8.2. 80 will be equal to AB divided by 2. Why did we say that? Because we know that line from center perpendicular to the chord. That's the reason. Line from the center perpendicular to the chord. What was our AB? Our AB was 40. Then our 80 will now be 20. Then we have our mark. Then now let's go to 8.2.2.2. Now they say that calculate okay, they're saying that if OS is equal to 7/15 OT, calculate and I'm saying calculate OA of the circle. OA of the circle, where OA is the radius. Okay, cool. So now I must calculate OA. So now we know that OS is equal to 7 over 15 OT. So when we're writing this, we know that when we're dividing both sides by OT, divide both sides by OT, it will be OS over OT is equal to 7 over 15. So now we already know that OS is 7, OT is 15. See, we already know that because of this. Then now, let's calculate OA. Now we know that that's not going to take much of our time. Okay, because now we already know that OS, let me just write this. So we're actually saying that let OS be equal to 7 and OT be equal to 15 so that you can actually see what I'm talking about. So now you can say that, please, when you're writing, write all those triangles so that we can actually see what you are calculating. So that in triangle A or T, there are many triangles in this instance. So you must speak about this specific triangle which you are dealing with. So in triangle A or T, what do we see? We see that AO squared is equal to 20 squared plus 15 squared. Then now we need AO. We square both sides. We square both sides. This and this will cancel. Then now we have our AO to be equal to 20 squared is 400, 15 squared is 225. But you use your calculator, then you use under the square root so that you get your answer. So then therefore we have our AO to be 25. Then now we have our AO to be 25. So basically here we were actually just testing and proving. So now also we can now look at another triangle. In triangle AOS, the other triangle, so that we can be able to use that 7. So what do we know? We know that OA, which is the radius, OA squared is the same as 7 squared plus 24 squared. How did we get 24? We said that that line, the long line is AC is equal to 48. So we divide by 2 the same way we did on 8.2.1. Then we divide it, then we get 24 centimeters. The reason is line from the center perpendicular to the chord. Now it's gonna be 7 squared plus 24 squared. Then the same applies. OA squared is equal to square root of 7 squared plus 24 squared. Then this and this will cancel. Then we now have our OA to be same as 25. So always show these two sides that OA is 25 and also OA is 25. Let me just write this as OA as well. Yes, OA, it doesn't matter, anywhere which you write is perfect. Then our OA is equal to 25. Our OA is equal to 25. So therefore we can actually conclude that OA is equal to 25. Then you have your marks. So that's how you calculate that one. You see that the boss is not hard. Euclidean geometry is not hard. You must be able to analyze your question the same way I was doing. It doesn't change. Analyze the same way always. Then you will get your answer. Now, this is the last question of the day. Let me see if it has everything which I need. Okay, let me do this. Last question, 10.2. Because these ones, they are almost the same. This one you prove, you know how to prove. The proof is on the video which we did on analytical geometry as well. We prove using that same equation. So let's do okay, let's just do question 9. But question 9 doesn't have everything I want. Let's do this one, the last question, question 10. Why? Because question 10 has the application of grade 12 work. Okay. So now let's do question 10.2. 10.1 you prove, guys. That's prop theorem, proportionality theorem. So now let's do 10.2. Due to time. So let's do 10.2 due to time. So what do we have in 10.2? Maximize it. Great. So in the diagram, HLKF, where is H? HKLF, okay, is a cyclic quad. HLKF is a cyclic quadrilateral. So we already know that L2 plus F2, the 180 degrees. Why? We know that the reason being that they supplementary when you add them according to the cyclic quad. Then we're also given that the codes HL, where is HL? Okay, HL and FK are produced. Where is FK? Okay, we can see the codes, they are produced to meet at M. Okay, those codes, they are produced to meet at M. So we are also told that MK is X and ML is Y. Then LH is equal to HG. LH is equal to HG. So those two sides are equal to each other. Then we're also seeing our parallel lines that KL is parallel to FG. Now, we are also told that KF is 2x and MK is x, and that's L. So now we can actually apply our prop theorem. This is a nice question. This is a nice question. This is what we were looking for. Right. Now let's solve it. The first question says, give a reason why G, F, and M is equal to LKM. Give a reason why G, this angle F, and angle K, they are equal to each other. As we were saying in the diagram, why are they equal to each other? Why are they equal to each other? Why are we saying that GFM is equal to LKM? Why are we saying that? Because we are seeing that they are parallel side. FG is parallel to KL. So we know that when an F is formed, this angle is equal to this angle. Why? Because they are corresponding angles. So why? The reason being these two are equal to each other. Why? Because they are corresponding angles. Then you state the parallel side. The parallel side is KL, is parallel to FG. Okay, state that parallel side. There is a mark for stating parallel side. So corresponding angles, provided that KL is parallel to FG. Now on 10.2.2.2 on A, then they say prove that GH is equal to Y. How can we prove that? Let me just write required to prove GH is equal to Y. How can we prove that GH is equal to Y? We only know the fact that ML is Y. So now they are saying that prove that GH is also Y. Prove that GH is also Y. Now, what do we know? We know that GL over LM is equal to FK over KM. As you can see on the diagram, they equate to each other. Why? It's prop theorem. That's prop theorem, guys. That's proportionality theorem. Then also we state the parallel side that GF now is parallel to LK. Okay, always state the parallel side when you are using the parallel side. So now we know that GL over ML is equal to 2x over x. And what do we know? We know that GL is equal to GH. We know that. So now it will be the same. Also, it's going to be GL over Y is equal to 2x over x. So that will be divide each other. Then we are left with, let me just use 2 because 2 over 1. Then we know that GL is the same as so this GL is the same as 2GH over Y is equal to 2. Okay, then now we need GH, so it's gonna be cross multiply, so we have 2GH is equal to 2Y, then we divide both sides by 2, divide both sides by 2, then therefore we have our GH to be equal to Y. So we have proven that it's equal to Y. How did we do that? We first wrote that GL over LM is equal to FK over KM, looking on our diagram. And after that, we wrote our reason that it's prop theorem provided that GF is parallel to LK. Then also now we highlighted the fact that x divided by x is 1. So also we know that GL is the same as 2GH. So after that, we can actually solve for, and we can actually see that GH is equal to Y. We can actually see that GH is equal to Y. We can actually see that GH is equal to Y. We can actually see that GH is equal to Y. Okay, so we say that GL over ML is equal to FK over MK. Then now we know that LH is equivalent to GH. So if we add the two, let me just write this so that I also highlight this fact. So it's the same. Why am I saying 2GH? I hear someone asking me that. It's because LH is equal to GH. So since they are equal to each other, what does this mean? It means that if LH is X, also GH is X. So it's the same as the total length of GL is equal to X plus X, or let me just not use X to confuse people. Let me just say it's equal to LH plus GH. But knowing that LH and GH, they are the same, so it's going to be GH plus GH. Then GH plus GH is 2GH. Then after that, we can actually see that that is our answer. We can actually see that is our answer. Actually see that is our answer. So that is important, guys, to be able to see well and properly so that you don't doubt your answer. Okay, so we say that LH is equal to GH. So that's why on the part of GL, we no longer substituted with GL, we substituted with 2GH after we did this calculation, because it's relevant to what we are asked. Now, the next question now is asking. Next question is asking, prove that, let's write as well, required to prove. What are we required to prove? We are required to prove that the triangle MFH is similar to triangle MGF. So now we are required to prove that these two triangles, they are similar to each other. So how can we do that? How can we do that? Triangle MFH, triangle MFH, and triangle MGF. So what do you do when you're given this instance? The first thing which you're supposed to do, guys, I always urge is to start by saying that in triangle MFH and triangle MGF. Why? So that you don't get confused. Write your triangles as they are. In triangle MFH and triangle MGF. Don't say that triangle MFH is similar to, without you proving. So you are required to prove that these two triangles, they are similar. So in order for you to be able to prove that, you start by separating that in triangle MFH and in triangle MGF, so that you can be able to see in both triangles simultaneously, separately. So what do we see? We can actually see that angle K1 is equal to GFM. Why? They are corresponding angles, provided that GF or FG is parallel to LK. Okay. So we can actually see that. So now we can actually see that as well. Okay. So we now know that f and k1, they're equal to each other. Or we can actually say that LKM, you have many reasons to say. You can actually also highlight the fact that LKM, this one, is the same as, or you can use K1. This is the same thing, guys. Angle K1 and angle, let me just do this so that you can see well. So K1 is the same as LKM, which can also be equal to MHF. Why are they equal to each other? Because we can actually see that it is an exterior angle of cyclic quad. Exterior angle of a cyclic quad. Now we already have 1, 2, 3 marks. Now let's now go forward now. So now we can actually see that MHF is equal to GFM. Why? They are both equal to angle K1. Then now we can actually end up having angle M is equal to angle M. It's a common angle. Then we are also we now know that this one, they're equal to each other. So therefore now we can actually conclude that triangle MFH, now we just rearrange the alphabets, okay, is similar to triangle GFM. Angle. That's our reason. Angle. Then you get your 5 marks just for doing that. 5 marks, 5 straight marks. Then C, say that we must be able to calculate and prove that these things are GY over FH is 3x over 2. So we know that GF now, GF over MF FH sorry about that. So I'm saying GF over FH is equal to the length, which we know that is MF over MH. So GF over MF, GF over FH. Then also we can use MF over MH. So whatever you do on this triangle, you also do on this other triangle, so that we have equivalent things. What is the reason? Similar triangles. So now we are now using the similarity which we have proved already. So therefore we can actually conclude that GF over FH is equal to 3x over 2y. Okay. Then that's how you can actually prove it. Simple as that. 2y. It's as simple as that. Okay, it's as simple as that. Then the last question of the day. So now the last question D, they want us to determine. Let me read the question loudly. So on the last question, they want us to show that y over x is equal to square root of 3 over 2. Okay, how can we do that, guys? So we can actually use the fact that we know that MF over MH, or you can say MF, over MH is equal to MG, this MG here, over MF, over MH. So don't worry about many things. Calculate. What's the reason? Similar triangle. So now everything, now we are just referring to our similar triangles, which we have already proven in B. So now we know that this is 3x over 2y. So it's going to be equal to 3y over 3x. Okay. Then now we can actually see that it is the same as we cross multiply, then to be 3x squared. No, sorry. 9x squared is equal to 6y squared. then we must show that y over x. So we're gonna say y over x, so it's gonna be divide by x squared, divide by x squared, 6x squared. Let's divide both sides by 6x squared. So this side, sorry, yes, 6x. Now let me do this step by step so that you don't get confused. So we're gonna divide by y squared by 6, divide by 6. Then now we have y squared is equal to 9x squared over 6. Now we must divide by x squared, divide by x squared, divide by x squared. Then now we have y squared over x squared is equal to 9 over 6. Then now we know that this y squared over x squared, according to the exponents, is the same as y over x squared is equal to 9 over 6. Then we square both sides. Then that will be y over x is equal to 3 over 2. Square root 3 over 2. Okay, square root 3 over 2. Because when we deduce this, it's going to be 3 into 9 is 3, 3 into 6 is 2. So then now we have 9 y over x is equal to 3 over 2. So that is what I had for you guys for today. This is what I have for you guys for today. If there is anyone who has any question, please feel free to ask. And if it's your first time to join Yebo Tutor live, please do check our video. And in this instance, we are doing June preparation for analytical and Euclidean geometry. Go look for the more explained or detailed explanation on Euclidean geometry and analytical geometry as well. Explain them, then there are videos, then we'll actually assist you so that you have deeper understanding. Then you come to this one. Bear in mind that we are preparing for our June exams. Tell your friends that Yebo Tutor is preparing you for your June exams. Come, all of you, come and listen to us. Follow us on our Facebook. Ask your questions on our WhatsApp group. Till we meet again, I think tomorrow for chemistry. Have a good night. And may God be with you.